Hi everyone, I am ANY DAW. I'm a musician and a producer. This is the second tutorial of my brand new series in my effort to pass on my experience in music making and producing. This time it's about compressors. I'm not claiming that my methods are the only ones, but through my experience in music making, I'm confident in saying that what I will be showing to you guys will work. I'm doing this tutorial for two reasons. The first and obvious one is to show you what a compressor does. The second has to do with how a compressor is being applied to a specific sound or a track. So the first rule of compressing is that we don't compress unless we have to, simply because not all sounds need to be compressed. And to explain why, we need to understand how a compressor works. A compressor is a specialized tool that's been designed to lessen the harmonic distance between audio levels inside a sound. In layman's terms, it listens for the lowest in level element of a specific sound and it boosts it to reach the loudest, while at the same time it can reduce the level of the loudest. That inevitably leads to some loss in quality, especially in the harmonics of the compressed sound, which means that you only compress when you have to. So, when do you have to compress? When you need an evened out sound output, when you want to boost the presence of a specific frequency range within a sound, when you work with vocals and you need to add some presence in parts that have been sung or spoken with differences in audio levels, when we want to colorize or increase the loudness inside a track or a sound, when you sidechain. Regarding sidechaining, you can refer to the previous course that explains the procedure of ghost trigger sidechaining in depth. You don't have to compress when the audio level of a sound is low. There you can use the gain utility to boost it up. You don't have to compress because you think that the compressor will give you more fatness. That's not always correct. You don't have to compress when you're dealing with a short duration or aggressive sound like a kick drum or a snare drum. Applying compression directly on that sample will rarely give you the results you require. I recommend you use parallel compressing, a technique I will cover in one of the upcoming tutorials. So let's see the key features of a compressor. In every compressor in the market you will find the same 6 basic controls. Well, in most compressors in the market. Okay, so this is a standard compressor VST, one like the ones you will find in most DAWs. The basic 6 controls here are threshold, ratio, attack, release, gain, and output. Those are the basic elements of any compressor. What do they do though? Let's start from the threshold. Threshold is, in simple words, the point which the compressor will start working from. This means that the compressor will not work below a certain level or a sound pressure. The threshold understands decibels. You can pre-select or automate the threshold in order to have the compressor sensitivity active and start working according to the setting. Keep that in mind and let's see what the ratio does. The ratio is a logarithmic setting. In plain words, it's how much compression you will apply to a sound, but always after the threshold has been passed. For example, if you set the ratio to 3.1, the input signal will have to cross the threshold by 3 dB for the output level to increase by 1 dB overall. Sounds weird, but you'll see what I mean next. The attack is a setting that can be simply explained. It's how fast the compressor starts to work. Clean and easy. This measures in milliseconds. The release is a bit more complicated and has to do with the threshold as well. The release is not just when the compressor stops working, but it's how early the compressor stops after the signal goes below the threshold. So, have in mind that the threshold is like a line, like a switch, that regulates when the compressor works and how early it stops working, according to its setting. The gain regulates the level of the sound before it's been compressed. It's better to work with a lower signal instead of a loud one and try to increase the gain towards its 0. And finally the output. The output boosts the whole signal of the compressed sound. The vast majority of compressors, especially VST ones, have a knee setting also. The knee regulates the way a compressor starts working. In other words, its reaction. There's a soft knee, usually on the left, and a hard knee, usually on the right. Now that's a setting for the well-trained ear. Some producers may disregard the knee setting because they might not be able to hear what it's doing. But if you try sidechaining a softer sound like a pad and work your way around the knee, you'll be more able to listen to what it does. The knee has to do mostly with the producer's taste and aesthetic. So that roughly covers the main controls of a compressor. But what about compressor types? The most commonly used is the VCA. VCA stands for Voltage Controlled Amplification. There are all-arounders and use an integrated circuit to give you very, very precise control, which make them ideal for lots of different tasks. The opto, which means optical, describes the light-sensitive circuits that control the compression amount in optocompressors. They're usually slower reacting than other compressors, but this can be a desirable effect sometimes. The FET, or the field effect compressors, are emulations or actual hardware compressors that use transistors to emulate a valve sound, with more reliability, but with a higher signal-to-noise ratio. They are popular for vocals and great for drum compression also. So now I'm going to start using a compressor to demonstrate good and bad compression examples. We will use 4 different audio types: a kick loop, a sidechain hi-hat loop, an arpeggio, and a mid-range vocal. So let's listen to the kick loop uncompressed. Let's try to focus now. By adding a compressor at the sample and by keeping the threshold at -50 and the ratio at 0, the compressor won't work at all, as you can see from the level meter in the main window. By increasing the ratio and keeping the threshold at the lowest setting means that the compressor will listen to the whole energy of the sound from its lowest point. I'm gonna toggle it on and off so you can hear the difference. So what I can most definitely hear is that the first victim in the compression process is the ultra low end. The subsonic energy in the kick is gone and it has given its place to the mid-range part of the sample, making it sound more hollow in a way. This happens because the sample has a stronger level in the low end, so the compressor obviously tries to match the loud subs with the not so loud mids by killing the subs. What you finally achieve though is a punchier feeling, since the compressor is focusing on increasing the transient feel, which means that it boosts its nose, in other words, its highest frequencies. Let's listen again. What's also obvious is that the silent parts between the kicks are points that the compressor is also looking for. So the more I increase the compressor ratio, the more flat and evened out the sound will turn into. So the use of a compressor in kicks should be done with caution. What I can recommend though is that either you use the compressor in a parallel compression method through an auxiliary bus or through layering, thus achieving the desired fatness. I'll show you how to do layered compressing in a next tutorial, or simply how to make things sound fatter. So moving on to the next sample. Here we have a hi-hat loop. The loop is already sidechained in purpose, which means that it's already kind of bouncing. Let's hear it. So we can feel how the loop is bouncing every quarter because it's already recorded like that. Let's see what happens if I apply compressor in this loop, but I'm pretty sure that you will have guessed the result by now. For starters, let's set the threshold to the lowest possible setting. As I'm increasing the ratio, the compressor will turn this bouncy hi-hat loop into a flatter, more evened out sound. The more careful ear will notice that before the compression, some frequencies were not noticeable. I hope you heard that. That proves how dangerous the compressor can be, since it listens to everything in order to bring the sound to the desired outcome. There you are. These are the frequencies that simply were not there before the compression, or we didn't notice before the compression. The compressor did everything right though. It's not its fault that those frequencies were there before the compressor. It's ours because we compressed the sound at that level. This is what I was saying since the start of this tutorial. You have to be very careful when using a compressor. Now let's move on to the next sample, the arpeggio. First, let's hear it without compression. So this arpeggio will turn to cream once we compress it. Let's start as usual with a threshold to the lowest setting. I believe that the compressor will focus on this part of the EQ and on the nose of the arp also around 5000 Hz. I also believe that it will suppress the level of the outcome a lot because it's too loud in different harmonic regions. Let's see what will happen. I'm going to go full compression. So the arpeggio lost most of its dynamic. The noise did went up, but since a compressor can only work as fast as its algorithm allows, it failed in adequately compressing the sample, which of course did not need to be compressed also. By setting the threshold level above 20 dB, the compressor is less aggressive and has more time to process the information. But again, it's failed to give the presence we thought it would give. But when is a compressor absolutely necessary? On the next example, we will use one of my vocals. Let's hear it. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. Okay, now I'm gonna play it again, but this time try to focus on the differences in audio levels, as well as the noise that can be perceived from the room acoustics, and another noise which sounds like it's from electricity, like ground noise. Listen to it again. So the first rule of compressing is that we don't compress unless we have to. By applying compressor to the sample, again starting with 0 ratio and the lowest threshold, we can hear that some of the parts in my narration, especially the part where I'm saying unless, which is louder, have become more aggressive. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. This is because it's too short and too sudden and the compressor doesn't have time to react. We can fix this with the attack knob. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. Or we can increase the threshold setting so we can narrow the range of the compressed region, thus making it less sensitive. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. What's going to happen now if we increase the threshold and leave the ratio as is? Let's hear with the compressor active, and I will toggle on and off to give you the feeling. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. Again, like in the previous examples, the low end is gone, but since this is a vocal, we don't care much. The compression has turned it into a more even, more balanced narration, and everything sounds smooth. Now, this is a desirable effect, but we can compress even more. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. So the first rule of compressing is that we don't compress unless we have to. Remember that you can adjust the moment the compressor starts working from the attack knob, so you can regulate parts in a vocal that sound louder in order to turn them into sounding more normal and keeping the rest of the vocal perfectly compressed. I understand that the way a compressor works may be a complicated subject for a lot of people to understand or comprehend. As a general advice, I suggest you work the same sample on alternate channels in your DAW by using different compressor types and more or less the same settings before you choose the right one. Keep in mind that the compressor levels the sound. Sometimes this is the objective, but in most cases it's not. But because it messes with the energy of the sound, you always have to be cautious and smart. So that was my first tutorial on compressors. We will go in depth at some point, bear with me, this tutorial series has just started. I intend to cover multi-band compressors and limiters also, as well as give you examples of the same sound with different compressor types. But for the time being, and because I don't want this tutorial to last for 2 hours, the general crash course on how to compress is over. Thanks for being with me, guys. Please consider subscribing to my channel in order to help me keep the weirdness rolling. Take care and see you soon.